Hello, and welcome to another Check on Learning. So this is Check on Learning for 6.1, Rational Exponents and Nth Roots. So let's see how we can do. So let's get my screen kind of sort of looking pretty. Let's see my calculator in the background. We'll need that. All right, so to get us started, prove that fifth root of a is equal to a to the power of n can be written as that. Okay, so I'm going to just do it first on the screen, and then we can look at these, whatever answers they have. So when it says prove that this is equal to that, that means that we start with this first expression, and we go from there. So we've got the fifth root of a is equal to a to the nth power. Okay, so if I wanted to get rid of this fifth root, I would take both sides and raise them both to the power of 5, right? So that means that, so I'll just write everything out. To the power of 5 equals a n to the power of 5. So using our exponent rules, this cancels out with that, so then we just have a left over. And then again, our exponent rules, those just get multiplied together. So then we have a 5n, and a to the no power is assumed that there's a 1 there, not 0. Anything raised to the 0th power is 1. So a to the first power is a. So we've got a to the first power is equal to a to the 5nth power. So we can just set those exponents equal to each other. And so then we do some algebra. Oops. There we go. So n is equal to 1/5, which then means that fifth root of a is equal to a to the 1/5, because we proved that n equals 1/5. Okay, so now let's see. So look down there at your answers, and let's see which ones work. So, okay, that's their given. Raise both sides to the power of 5. Where's our options? Here you go. This looks like both powers being raised to the power of 5. So then we have that, which is, we'll go with the definition of fifth root, because that's the reason that this fifth root to the raised to the fifth power is cancel out, definition of fifth root. And then they use the power of a power property, so probably there, changing that to just a5n. So let's see here, a5n, here we go. Then we have the a1 equals a to the 5nth. Definition of first power. I guess that's the definition of first power. I mean, it is. It's just weird how they write it. Anyway, so let's see here. The bases are the same, so equate the exponents. So 1 equals 5n. Solve for n. N equals 1/5. Substitution. We're done. So there you go. There's your first one. Introducing you all to proofs. The proofs are amazing and fantastic. So let's see here. This next one says, what are two different ways to evaluate 216 to the 2/3 power, other than shoving it into your calculator, which we'll talk about. So the first way is you can do either the top of the fraction first or the bottom of the fraction first? So we'll start off with doing the, trying to figure out what answers would work best for them, but whatever. So we'll do the bottom of the fraction first. So if we do the bottom of the fraction, so that's the same as the cubed root of 216. Oh no, there goes my cube root. Cube root of 216. And then we take that answer and we square it. So then, because I totally know the cubed root of 116, is it 72? That's not right. Is totally 6, right? Everybody knew that. So that is equal to, you probably could have seen it over here too, but whatever. So that is equal to 6 times 6 times 6. So 216 is equal to that. So then we have 6 on the inside of the parentheses and then squared, and then that's going to equal 36. The 6 times 6 is 36. So the other way to do that, we'll do it in green, is to start with the top part of the fraction first. So you're going to take 216 squared, and then you're going to raise all of that to the third root. So 216 squared, I'm just going to totally do that in my head. 216 squared is a big freaking number. So that's going to be 4, 6, 6, 5, 6. Cubed root. And then, totally just in my head, I'm going to figure out what the cubed root of that is. Totally just in my head. I'm just doing it all in my head. Oh, look, 36. Totally got it. Makes perfect sense. And yes, I will show you how to do all this on your calculator. I mean, in your head later. So, select all methods that apply. Got it. So, let's see here. Where's our first method where we did the cube root first? So, this one seems like it's the cube root. You did the cube root and 6 squared equals 36. Yeah, that's wrong. And I'm looking at this last one. I never got that number, so I'm assuming that that's wrong. Yeah, they just dumped. Anyway, so that's our first method. That's our method in blue. Our method in green, we did the squared first. So like this, we got that 4,600. It's like an expensive car. So we'll go with those two. So again, in reality, it does not make a bit of difference whether you use the method on the left or the method on the right. It really doesn't matter. What I am noticing myself, it is typically easier to work with the bottom one first because it's a smaller number and it's easier to try to figure out the square root, the cube root, the fourth root, whatever. But this is going to be something that I would probably use a calculator. Boop. Write the expression as a radical expression. If the expression is equivalent to an integer, write the integer. That's integer. So write the expression as a radical expression. So the radical is just this symbol. Anytime you see that, that means that it's looking for the radical version. So the radical version of this would be the fourth root of 49, and you can either put the 7th squared on the inside, or you can put the 7th squared on the outside. It doesn't matter. So let's see if there's an integer. I can figure that out with 49. I'm just going to take square root twice. Oops. Square root 49 is 7, and then the square root of 7 is not a happy number. And just to make sure, 49 to the power 1 divided by 4. So there's not an integer. So let's see here. We got this little guy right here. So we got a 4. We got 49. And then might as well raise the inside of that to the 7th power. So there you go. Write the expression as a radical expression. The expression is equal to an integer, write that into integer. So do they actually want us to write out? Yeah, they do it. Okay. So this 100 raised to the 3/2 power. So we can rewrite that as the square root of 100, and then we can raise that to the 3rd power. So the square root of 100 is kind of easy to figure out. That is equal to 10. 10 times 10 is 100. So we've got 10 raised to the power of 3, which is equal to, oh my goodness, I don't know. What is 100 times 100? 10,000. 1,000. See, I knew I was going to get one of my zeros wrong. Yeah, I'm sorry. I don't know what I was thinking. So 1,000. So 10 times 10 times 10. So they want us to write it as a radical expression. We can use that one because, so again, this is the same as square root. So that's just some common math nomenclature. So that responds or represents square root. So 100, then we can raise that to the 3rd power equals $1,000. Next. Oh, look, we're doing the same thing again. Oh, except this is with a rational exponent. Even easier. Maybe. Might be easier for you, might not be. It's easier if you can write 2, 4, 3 is going to be raised. So this is always on top. This is always on bottom of your fraction. So it's going to be raised to the 3/5. So I'm just going to show you right now how to enter this into your calculator. So especially once you get it into the fraction form, it's much easier, in my humble opinion. Let's get out of this. So as a reminder, we've got 2, 4, 3 to the 3/5. I'm going to get rid of all this stuff so that you can actually see the calculator. So to enter that into your calculator, you're just going to type in 243. And remember this little guy, this is raised to the power of. Now, your all's calculators kind of give you this little exponent thing here. My old one doesn't. So let's see what happens. So if you just put 3 divided by 5. Okay, good. So it stays all up in there. So if you have an older calculator, one way to ensure that everything is in the spot that you want it to be is put it all in parentheses. So you can do 3 divided by 5 and then close parentheses, and an older calculator would still be able to figure that one out. Enter. Oh look, it is an integer, 27. Totally knew that, right? Come on, pencil. So let's get rid of our calculator. So 243 to the power of 3 divided by 5 equals 27. Right? Cool. Next. Oh no, we have a negative under a square root. But Mr. Lin, it's not a square root. It's a cube root, so you can have a negative under there. Not a problem. Write an expression with a rational exponent, so it's going to be the same thing. So negative 216 raised to the power of 2/3. Remember, this goes on top, this goes on bottom. So I'm going to end up doing this on my calculator anyway. So we'll write negative 216 to the 2/3 anyway. Pull my calculator back up. So negative 216 to the power of 2 divided by 3 equals negative 36. Now, if we were to put that negative sign underneath a square root, we'd get like a syntax error or something like that. You can't do that. But you can do it here because it is a cube root, not a square root. So let's hear what we got. Negative 36. Cool. Negative 36. I'm going to write that down before I forget it. So we're going to have negative 216 raised to the power of 2 divided by, I don't know why they don't have divided by on this part, but you have to use your calculator. I'm sorry, your keyboard. And then let's get out of that. Equals negative 36. Ooh, a word problem. So the total wages, W, in a metropolitan area compared to its total population can be approximated by the function blah, where A is a constant. Part A. What are the total wages for a metropolitan area with a population of that people in terms of A? So total population of P. So that just means we're going to shove that number in for P, right? So that's going to look like A. We could use the multiplication sign when doing normal algebra. If you have a letter next to a number, it is assumed that is multiplied together. 1, 2, 3. 1, 2, 3. To the power of... Oh, do we have to figure this out ourselves? I think that's what we got to do. Yeah, that's fine. The 9/8. I'm totally going to do that in my head. So 3,000, or I guess that's million, raised to the power of 9/8 is equal to, move face, you're in my way. Just making sure I did everything right. It's equal to that number. So I'm going to write that number down. 1,9,3,5,5,3,5,8,4.44. So we're just going to shove that number right in there instead of 3,000. So it didn't give us the exponents. 5, 3, 5, 8, 4, 4. Oops. There's a 0.44 on round any values the nearest whole number, so I don't need that. So fun, quick way to check yourself. So if your exponent is greater than 1, then your number is going to get bigger, like ours did. If your exponent is less than 1, or some fractional that is less than 1, it's going to get smaller. So just one way to kind of continue to check yourself, make sure that you're entering it in to your calculator correctly. So which of the following sentences correctly compares the total wages of metropolitan area with a population of that people to total wages for a metropolitan area with a population of that people? Okay, so they want us to compare the two. So we've got our top number. So we're going to make a fraction. We're going to make a ratio. And we need our bottom number of 75, 0 to the power of 9/8. So again, we're going to come back to our calculator. Okay, so we can either retype this number, or we can use a little function called the answer or the entry button. So notice right here in blue it says A and S, that stands for the answer. So what I'm going to do is I'm going to do this entire equation in one line on the calculator. So I want and remember, we're taking this number on top and our new number on bottom. So we're going to take our former answer, so that's going to take that number right there. We're going to divide by, and I'm using parentheses because parentheses are your friend. So the power of 9 divided by 8. So then we want to get out of the power. So this is just going to ensure that all of this happens inside the parentheses first, and then it's going to take the answer divided by that answer, and then we will have, so 4.76. So we're going to write that down. So let's see what answers they have. The total wages of metropolitan area with 3,000 is about 2.66 times the total wages, 4.76 times the total wages. That's going the opposite direction, and that's just the wrong number. So that's the one we'll go with, 4.76. So there you go. Check on learning for section 6.1. Check.